Good afternoon, everyone. Welcome to today's session. My name is Shri Krishna. I'm your Learner Success Manager for the day. Before we go ahead with the session, please let me know if my voice is loud and clear. You can confirm in chat box. Thank you for your confirmation. Let me do a quick audio check with our instructor. Hi Rahul. For audio confirmation, please let me know if my voice is loud and clear.
Yes, Shri Krishna, it's loud and clear.
Thank you. We can also hear you clearly. Now I will make you the presentator so we can get started with the session. Happy learning, everyone.
Thank you, Shri Krishna. Hello, everyone. Let's wait for a couple of minutes. Hello everyone. Good morning. Okay, so let's start with the class. So just a verbal recap of what we did yesterday. So in yesterday's class, we started with Matplotlib, and then we moved into uh, discussing the theoretical part about the statistics and various measures of it, and then we moved back to the Matplotlib code, and that is what we'll be doing today continuously as well. So yes. So and before moving ahead, any questions, any doubts, anyone, please put in the chat. Okay. So let me share the screen and let's continue with the matplotlib part. I hope my screen is visible. So we were on the histogram part. So we covered the bar plot and we were discussing about the histogram. So histograms are used for understanding the data distribution and analyzing the frequency of the data. Okay, you might have studied this during your schools or your colleges as well. So simply helps us in understanding the data distribution or how the data is basically like is it skewed or not skewed. Okay, so this is what a histogram is, and we have bins or buckets at the bottom. That is what histogram forms. For example, this is my total bill column, and the minimum and maximum values are this 3 and 50. And what I'm doing is I'm simply making some buckets over here 0 to 5, 5 to 10, 10 to 15, 15 to 20. It's simply a list, but now I'm using the pd.cut function on top of it to assign them bucket. For example, 16.99 falls into the 15 and 20 bucket. 10.34 falls within the 10 to 15 bucket. 21.01 falls within 20 to 25 bucket. So I'm simply assigning the values present in the total bill column to the buckets directly. This is what I'm trying to show you, that what histogram does at the back end. You pass any data to the histogram, it will itself make buckets of equal size and will plot the data. But the intent of me doing this was just to show you over here how that thing is getting done. Okay. So, and if we look at the value counts of the buckets, so this is the value counts. Okay, just give me a second. I need to run this. So if I run this, it tells that most number of entries are within 50 to 20, 15 to 20 bucket, 63 entries from 10 to 15 bucket, and 41 entries from 20 to 25 bucket. But my total bill column is exactly same. Now, in histogram, you do not need to do this. The intent of me was just to show how it's getting divided into bucket and how it is getting stored. That's it. So what is happening is, so as how to make a histogram by using simply plt.hist, H-I-S-T, df total bill, pass in the bins which you want. So it will make up the bins like 0 to 5, 5 to 10, 10 to 15, 15 to 20, and 20 to 25 like this. Hist type, like you want the histogram in type of bar. You can specify step or bar stacked as well. So simply how it will simply change it to the line part basically. So if I make it step, so this is how the histogram looks. Okay. And R width, of course, determines the width of the histogram, alpha intensity of the histogram. Then I'm saying plt.x label, total bill intervals. That is what it's shown over here. Then I'm saying plt.xtext. So this is new for you. So you can even control the values that should be presented on x-axis. How? By using the xtext argument. So inside plt.xtext, you pass in a list or tuple with the numbers that you would only want to show, and matplotlib will only show those numbers at the bottom now. So I'm saying plt.xtext bins, so you can see that the 0, 5, 10, 15 are shown down here. Then plt.y label, frequency flash occurrences, that is what I've written over here. Then plt.y ticks, again simply controlling the ticks on y axis. Then plt.title, histogram, and plt.show, simply to show the histogram. So this is how the histogram comes up. Okay, so this is how the histogram comes up. Now, to make a grid in your graphs, that is also possible. How? By simply using plt.grid. True indicates that you would want to have a grid in your graph. Color is equal to blue states that the color of the grid, line style, line width, alpha, all the other parameters are exactly same. And you can see how this forms up. Okay. Now, if I would want to add histograms to, I want to add grids to my existing graphs, can I do that? Yes, by simply using plt.grid, pass in this parameter, like you want the grid in your graphs, plt.hist, pass in the histogram data that you would want to pass over here, like this. Then plt.xlabel, xtext, like the whole remaining code remains the same. There is no change in the code at all. There is no change in the code. I'm simply adding a PLT grid to add grids to my graph. Once I run this, this is how it comes out. Okay, so this is how you can add grids. Yes, Lakshmi. Histogram is a graph, Sundar, used for getting the frequency of the buckets. Okay, so you simply pass in x-axis on y-axis. Sorry, you do not pass any data for specifically for y-axis. You simply pass in the bins in case if we want to that these are the bucket size 0 to 5, 5 to 10, 10 to 15, 15 to 20. This is what you pass. And on x-axis, then I'm simply putting x-axis arguments, y-axis arguments, and then simply get a histogram. Now histogram also helps you to look at the skewness of your data. So what is the skewness of the data essentially? So with how skewed my data is it very much present on the left axis, left side or right side? So it helps us to look into the skewness of the data as well. So hence now let's move to the blackboard and talk about measures of shape, which involves skewness and kurtosis. So just give me a second. Let me open the blackboard. So yesterday studied statistics and its types, followed by the measures, correct? So measures of central tendency, measures of variability, measures of relationship, correct? So today we'll be studying about measures of shape. So let's start. So measures of shape, these are the tools that are simply used to observe the distribution of data. Distribution of data, like how your data is spread, how your data is distributed. Okay. First parameter that we study in this is skewness. So skewness is simply a measure that helps us in seeing the asymmetry present in your data distribution. For example, uh, if you're having a data like this, and let's say if your data is like this, so it's very much elongated on this side, whereas on this side it is not at all elongated. So skewness helps you look into these parts, whereas a perfectly symmetrical data looks like this. So it says that it helps in measuring the asymmetry. Okay, so measures the asymmetry of data distribution around its mean. It can be positive, negative, and zero. So let me make the graph and then talk about these. So inside this, the first one is positive skewness. This kind of distribution of our data would be positive skewness. So mean would fall over here, let's say. In this kind of data, the mean will fall over here. This is where the median comes in. And this is where mode comes in. And in this, mean is greater than median. Okay. So positive skewness, as you can see, the tail is longer on the right side. So this kind of distribution is known as the data is positive skewed, okay, or right skewed. Okay, examples: income distribution, of people. Okay, that most of the people are earning around the same amount over here, and very few people are making a lot higher, which is very far away from the normal amount. So very far away as well. So this is what that particular information is specifying. Second could be age of population in India. So most people being young. Okay, so very few people are old and most people are young and are kind of within the bracket of 10 to 30 something. and very few people within this particular bracket. Okay, so age of India would be another example for this. Then comes the second one, which is negative skewed. So in this, the data has longer tail on left side, means that there are extreme values more on the left side. Otherwise, most of the data is consolidated on the right side. Okay. Example of this would be age of taking retirement. Okay, age of taking retirement. So this is a left skewed or negatively skewed. The third one is no skew. In this kind of data, the mean median mode is exactly same. 50% of data is on one side and 50% of data is on one side. So this is also what normal distribution is. We call this as normal distribution. Another name of this distribution is also known as Gaussian distribution. Okay. Example to this would be IQ of people. Like if you simply go and note down the IQ of a lot of population, so most of them having very few IQ, most of them having a very high IQ, and most of them are having a average range of the IQ that is present with normal people. Okay, so IQ of people, if you note down the height of people, very few people which are short, very few people which are very tall, most of the population is in between. Same with weight of the people. Okay, all these falls under this part. Okay, so this is when there is no skewness. Negative skewness when left tail is longer. Right, positive skewness or right skew when the right tail is longer. Okay, so we just talked about those kind of data. Now the second one is kurtosis. So we are currently studying the measures of shape, and we just studied skewness. And the second one is kurtosis. It measures how peaked the data distribution is. So let me try to bring in an image for this so that all of you can simply understand. Give me a second. So this is what is kurtosis. Okay, so We have three types of kurtosis: platykurtic, platykurtic, leptokurtic, and then we have normal distribution, like which is your normal data. The relative weakness, we kind of use it. So this is simply mesokurtic, also known as normal distribution. The one we were looking at above also is the normal distribution. No skewness, normal distribution. Okay. So same is the case over here. Uh, Mesokurtic is simply the reference point to determine sometimes that okay, this is lepto and this is platykurtic. Okay. Leptokurtic is also known as positive kurtosis. Okay. Platykurtic is also known as negative kurtosis. So this is simply to look into how peaked the data is. Okay. How most of the data is kind of, for example, if I look at leptokurtic, you can see most of the data is within very singles, like very close to each, at very center of the whole distribution. Whereas at tails, there is merely no data. Okay, you can see that. Whereas in mesokurtic, which we consider as a normal or the distribution that is taken into relativeness, is still having good amount of data on the tails. Like as you can see, this particular area I'm referring to. Okay, whereas platykurtic is having a spread of the data across very much. Okay, compared to leptokurtic and mesokurtic. In platykurtic, the spread of the data is much higher. There is a fat tails, as you can see, which indicates that okay, even the extreme values are also more in this case. So that is what is platykurtic. Okay, so yes, now this is what I wanted to talk about measures of shape. So we talked about skewness and we talked about the kurtosis. Now let's move back to the matplotlib code and look into the histogram and see how it is. So if you look over here, you can see that my data is a bit, first of all, right skewed, correct? It is right skewed, that is positive skewness. There is extreme values present on the right side of the data. The opposite to this is left skew. Okay, so this is what I wanted to talk about in terms of shape, measures of shape. That how you can understand whether your data is leptokurtic, platykurtic, right skewed, left skewed, no skewness, and that all comes over here. Now moving ahead. So I hope everyone is clear till this point. Any questions, any doubts so far? Trends of data are seen through line charts, Siddharth, not through histogram. You want to see trends, you will be able to see through line charts. Histogram does not show you the trend. Histogram shows you the shape of your data, distribution of your data, skewness in your data. Okay, moving ahead. Now let's talk about box plots. So what are box plots first of all used for? Just to show this is what is a box plot. Okay, box plots are used for identifying outliers present in your data. Box plots are used for identifying outliers in your data. So we'll be now talking about what are outliers first, because then only we'll be able to understand the box plots. And after understanding the outliers, then we'll come back to this graph and look at this into detail. So moving back to the blackboard. Okay, outliers. So outliers are the data points So outliers are data points in the data that significantly differ from other data points in the data set. You can see them, these are some extreme values. These points could be very extreme numbers, could be very low values, could be very high values with respect to your data. So hence they are also called as outliers. Just to give you an example, let's say example is we are having a temperature of a city at everyday level. So these are what are outliers, some extreme values that are present in the data. Now they can be due to sensor error, so they can arise due to the sensor errors or data collection issues or data entry issues, or they can be in some cases valid data points, but still they are extreme. For example, just to mention this, let's say if I try to write profit in, let's say, uh, share market, or or a business, whatever you can write, totally up to you. So it could be just simply in thousands, 10,000, 15,000, 10 lakh, or a million basically. Okay, let me simply write 1 mil. Okay, 50K, something like this. But then there would be some extreme values. Then there could be some extreme values. Example, uh, it could be 80 million, 1 billion. These kind of values could be there, correct? So these are valid data points, but extreme. But they still can be called as outliers, because what plain sense outliers is that significantly differ from the rest of the data points. They can be simply nonsensical, invalid. For example, this kind of temperature 334 degree or minus 336 degree is not possible. It's simply an invalid data, whereas then you can have some extreme values which are valid. For example, profit in the business or some other thing. Okay, so all these things are possible. So in that case, it depends upon your data what you would call as invalid entry, essentially, that you would want to remove. So usually what do you do with outliers? Okay, so either you remove outliers. So for example, 334 minus 336. So either you remove them or you simply replace them with a data point that is reasonable. When I say data point is reasonable, like what should be actually present over there. Minus 334, minus 336 could be 34 or 36 degrees Celsius. And the last third digit has been accidentally added, or the decimal was forgotten and the front sign is also by default mistake. So you either remove them completely or you simply replace them with what the data should come over there. And in case if they are valid entries, you tend to keep them, or even if you want to normalize them, you tend to normalize them with respect to your data. So it's totally up to the user what the user wants to do with the outliers. Okay, but these two are the most common things. Either you remove them or you replace them with some common or reasonable value. Okay. Now the question comes, how to I identify outliers? So there are two ways to identify any outliers. Outliers, in fact, any measuring case in statistics, if you want to do or understand this, there are always two techniques. One is by simply plotting a graph, and the second one is by doing a test or using some kind of equation or thesis or some kind of a way to figure out if that particular point is outlier or not. Same goes for trend as well. So let's say if you want to identify trend in your data, either you simply draw a graph, you will be able to see a trend, or there are various methods which you can write that okay, if this value is constantly increasing, minimum value minus maximum value is positive this much, that much. You write certain rules, and based on that, you say that okay, there is a trend. So even without looking at a graph, so that is what this particular thing indicates in front of you currently. So outliers can be the same way. Outliers can also be detected using two methods, either simply using graphs or by simple test or equations or some calculation methods that you might use. So for graphs, we tend to commonly use box plots. While in plots, and at times scatter plot, not the right plot to use for checking the outliers, but it can be also used to check the outliers. And same way, there are many methods as well that can be used for finding the outliers. So we'll be studying essentially these five: box plot, variant plot, scatter plot, and the interquartile range method. You already know now what interquartile range is. That is the Q3 minus Q1. We studied about that yesterday. Okay. And the second one is the Z-score method. We'll be talking about that as well. So first, let's start with the IQR method only, followed by then the box plot, and then the variant plot, and also the scatter plot. And Z-score method we'll be studying in the upcoming classes. Once we are done with the normal distribution, we'll be able to relate it. Now, what is IQR method? Let's talk about that. So if you remember IQR formula, okay, let's say this is your data. Okay, this is what is your IQR. So we say that we'll treat any number as outlier, any value if it is less than Q1 minus 1.5 times IQR. Means we are saying any value on this side, the outlier. Okay, any value which is less than Q1, which is this particular point. Okay, Q1 minus 1.5 times IQR. This is a commonly accepted method or commonly accepted multiplication factor as well in the space. Like we tend to multiply it with the 1.5 times IQR. So Q1 minus 1.5 times IQR, it will tell us that okay, this is a outlier. Same way, it is with respect to the outer value as well. It's called to outlier. Any value that is greater than Q3 times this is also outlier. So is a outlier. Okay, so this is the method, IQR method used for detecting outliers. We simply calculate the interquartile range, calculate the Q3 and Q1, and then simply we say Q1 minus 1.5 times IQR. If any value is less than that, so it is an outlier for us. Same way, Q3 plus 1.5 times IQR. If any value is bigger than that, we say it's an outlier for us. That is how the IQR method uses the technique to detect the outliers. Okay, as simple as that. It's quite simple and quite easy, in fact. Okay, so let me move to outlier detection code just to show you that how outliers are detected with the same code, like the thing that we talked about. Give me a second. Let me open up the Python code and then go through that. So I hope my screen is visible. So in this code, we'll be looking into, first of all, how you can detect outliers in a data. And we just talked about what are outliers and how we do detect them. And we talked about the IQR method. We'll be also talking about the box plot and scatter plot in this code as well. Okay. So the impact of outlier, first of all, it causes serious issues in the statistical analysis because it skews the data, has a significant impact on the mean as well as the standard deviation. Okay, so first we are defining a data. So I'm making some data. Okay, and this data has 1000 data points just to show you. So these are all the data points present in my data. Okay, data is simply from 50 to 53 with a step size of 0.003. Okay, hence we have 1000 data points. Now first I'm simply calculating the Q1 and Q3 percentiles. How? By passing the data in the np.quantile function and then specifying that I want 25th and 75th percentile. Once you run this, so it tells you that okay, your Q1 and Q3 are 50.74 and 52.24 respectively. And how is IQR calculated? By simply Q3 minus Q1, so which gives us the value 1.49. Now what we are doing is we are just to show you the lower fences. So Q1 minus 1.5 times IQR is 48. So any value which is less than 48 will be treated as outlier. For example, if 45 comes, it will be treated as an outlier. Same way, any value greater than uh, this particular value will be treated as outlier. So why we are doing plus? Because on right side, so any value greater than 54.4449 will be treated as an outlier. So even 55 is a outlier in this case. This even 55 is outlier. Same way, let's create some other data. So I'm saying 52, 53, some big number, and having some big step size. So this is how my data looks in this 50, 10,000, 53, 20,000, 56, something, some huge spaces between the data. Same way I'm calculating the Q1 and Q3 quantiles, which are very, very high values now and very, very far away. So this data is not tightly packed. So when I say IQR, it comes out to be some big number. Okay. So now if I say Q1 minus 1.5 times IQR, it says that okay, this negative 26497,897 number is a outlier. So in this case, 45 or some kind of value will not be outlier. Even 4500 or minus 4500 in fact, or 45,000 or 450k, even that number is not an outlier in this case. Why so? Because it's a very significant value that we are getting as a lower fence. Now, just to show how scatter plot can be used, so what I'm doing is I'm making some data, 10, 12, 13, something like this, and I'm adding some data points in between, which are acting as outliers over here, like 80, 70, 60, 90, 100, minus 100, and then again the same range of the data in this time. So I'm having 42 data points. Now what if I simply plot the same data on x-axis and the same data on y-axis? Once I do this, you will be able to see that most of the data is tightly packed over here. Why so? Because that is how my data was over here. 10, 12, 13, 10, 12, 13, something like this. Okay, but there are certain points that are very far away. And these are these points, 80, 70, 60, 1900. Just indicating that, okay, there are some points that are very far away from your data. And same way, there are some points which are very far away from your normal data. Okay. And this is how scatter plot can be also used uh, to detect the outliers. Now, if I talk about box plot, so this is first of all what a box plot is. So the center box indicates Q1 and Q3 as the external edges, like this last line of the box is indicating Q1. This point is indicating Q3, and the centermost line is indicating the median. And the width of this particular box indicates the IQR, that is the interquartile range. And the minimum points over here are, so what is happening is that any points outside this, that is Q1 minus 1.5 times IQR, these are outlier over here. And same way Q3 plus 1.5 times IQR, these are outliers. You can there in your day-to-day data, you'll get outliers. So in real life, will you be making models on data, correct? That is what data science is. You make models on data, you work with data. So you are receiving the data. Won't you check if there are some extreme values or not? So that is where this concept is used to detect if your data has outliers or not. How will you detect? Using scatter plot, box plot, interquartile range method. So that is what we are currently talking about. So same way if I do a box plot of this, some 10, 12, something like this, and how to make a box plot, we'll see in the code as well. But by simply plt.boxplot, and this is how a box plot comes. So it says that okay, there are three outliers as you can see over here. Okay, and then again simply implementing the IQR method that I'm simply writing over here. So however, we have already seen this above, how you can kind of calculate these values, that any value less than this, any value greater than this is a outlier. But same thing is implemented over here as well. So simply calculating the Q1 and Q3 percentiles. These are our values. This is our data 1. So IQR is 3 for our data. So lower fence Q1 minus 1.5 times IQR, and Q3 plus 1.5 times IQR is the upper fence. Now I'm simply writing a list comprehension that for x in data 1, if x is lower than this or x is greater than this, simply append this to the outlier list. And if it is totally opposite, that x is greater than the lower fence and smaller than the upper fence, so it's a normal data point. A simple loop basically simply determining if the data point is less than a lower fence or greater than outer fence to detect outliers, nothing else. You can write this code with respect to your own logics as well, that's totally fine. So this tells that okay, 80, 70, 60, 90, 100, minus 100, these are outliers, whereas these are valid data entries. A simple way of segregating it, nothing else. And sometimes you'll see that people using, instead of 1.5 times, they're using 3 as well as to multiply and see that, like, make a logic of any point less than this or outside this is an outlier. Why so? Just they want to be very, very sure that only very extreme values are considered as outliers. That is the only reason of multiplying it with 3 rather than 1.5. Okay. So this is what outliers are, and what is the IQR method used for detecting the outliers. And we also looked into the scatter plot as well now. Just how scatter plot also helps you in looking if there are some points which are very far away from the normal distribution of your data, as well as the box plots that we looked at, how box plots can also help in identifying the outliers. Now let me do one thing. Let me share this code with you. Try to go through this. Try to understand what we are doing. Is it in line with the IQR method that we talked about? And once you are done, please write done. Then we'll move ahead and move to the matplotlib code back again and look into the violent plots and box plots. So stopping the share and sharing the code with all of you. Please give a thumbs up to the file if you're able to download it and save it and open it. Once you're done, I've uploaded the file in the chat. You will be having access to it. Once you're done, please let me know. Then we'll move ahead. Are you able to download the file? Okay. So please have a look and then do let me know. Once you're done, we'll move ahead. The purpose of identifying outliers, Jaya, is because they will be skewing the data, they will be impacting your models. If there are very extreme values in the data, they will be impacting your models. So we need to correct this, correct? So that our data and our modeling can be in line. Because minus 336 degrees Celsius, 334 degrees Celsius, these values are not possible. And this will be affecting the analysis in the modern pattern recognition technique as well, correct? Hence, we need to treat the outliers and correct them. Does it make sense? As I mentioned, outliers are extreme values to be. So if they're valid, it's up to you if you want to keep them. If they are wrong or wrong data inputs, so you'll try to remove them or correct them. So has everyone gone through the code? Has everyone gone through the code? Okay. So let me conduct the poll, then let's go for a break. Post the break, we'll continue with the matplotlib part. I hope everyone has polled. Ending the poll. Sharing the screen with a timer. So let's go for a break, everyone. Thank you. Hello everyone. There was a technical issue at my end, so had to uh, kind of sort it and then log in again. So system was frozen and had to log into another system. But yes, thank you for waiting, everyone. Okay, so let me share the screen and let's go through the matplotlib code now. I hope my screen is visible. Okay, so we were at box plot. So let's go through the box plot. So we just talked about the outliers, what outliers are, and how to detect them. And we also talked about the box plot as well as the scatter plot as well as the interquartile method, correct, IQR method, and how we can use that to detect the outliers. Post that I shared the code also with all of you, and all of you reviewed it as well, and I think we're able to understand the whole concept behind how we're able to detect the outliers. And we already looked at a box plot in that code that I shared with you, but yes, we'll be continuing in this code as well and see how we can make box plots. So what you are doing over here is, as I mentioned, box plot is used for detecting outliers and it gives an idea about skewness or distribution of your data as well. Again, but the main intent of box plot is to show the outliers, but you can understand the skewness or distribution of data a bit as well. Let's say this is your total will column. Now, if I do a scatter plot on top of it, tell me that okay, there are certain values further away. If I plot the same data on x-axis and y-axis, this gives you an idea about if there are any extreme values or not. Now, if I try to simply do a box plot over here, you can see. So plt.boxplot is the code for making a box plot using matplotlib. I'm simply passing the total bill column over here, and I'm simply saying vertical is equal to false, that I do not want a vertical box plot. Like if I make this true, so this is how it looks. Okay, this is a vertical box plot, and this is a horizontal box plot. And then I'm simply doing a plt.show. You can add grid lines as well in case if you want to add them in between like this. Okay, so totally up to you. But yes, so this is what a box plot looks like. Now moving to violin plots. And again, by simply looking at the median, you'll be able to understand if the data is skewed. Like if this median is completely in center, it gives you an idea about that, okay, the data looks very well close. But what if I simply, let's say, if you try to select some data, let's say tip. So tip seems to be same. Let's see for size. So can you see how the 50th and 25th quantile are very, very similar? So this shows that your data is a bit skewed on this part. Okay, median and 25th being exactly the same. So that gives you an idea about the data distribution, but again, not an ideal graph. At boxplot, main usage is to detect outliers. Okay, moving ahead, coming to violin plots. So violin plots are also used for detecting the outliers, as well as it shows the distribution of your data. It shows the distribution of your data. So first of all, how to make a violin plot? By simply using plt.violin plot, pass in the uh, data or the column for which you want to make the violin plot. Then simply specify the quantiles, like I'm saying 25th quantile, 50th quantile, 75th quantile. Okay, and then vertical is equal to false, means I want a horizontal box plot. Sorry, horizontal violin plot. And once you run it, you can see that this is how it generates. If you look closely over here now, so this shows you the distribution of your data as well. Okay, so that is what it is indicating over here. It shows you the distribution of the data. okay, or the density basically. And then plt.show simply shows you the violent plots. Now, matplotlib also has a lot of styles, existing styles present inside it. And what is the use of those? You can use those to simply beautify your graph or uh, change the default styles of your graph. For example, if you say from matplotlib import style and styles dot available and you run this, so this will show you all the styles that are available. First of all, you can see this over here. So many styles are available. Just to show you how they are different, like this is our violent plot, okay? Or let's say this is our normal histogram, how it was visible. This is how the default histogram looks like. But if you use different styles and if you set them, what happens is, for example, if I say Seaborn version 08 bright, and let's say use this style. So I will say style.use Seaborn version 8 bright. And now if I run this existing same code of the histogram, see how the color has changed. So it tends to change the outlook. Just to show you, let's say, for example, if I use BMH style, so you can see how it changes the style of the graph. Now this is having grids and a shaded background. Same way, if I use, let's say, dark background, you can see how the histogram is completely changed. Now it's dark in color. Okay, so all those things can be completely done. Same way fast. So it's up to you which style you like, or ggplot, which you would want to use. Okay, so for ggplot it's different. So every style is having its own views and those things. So it's up to you uh, if you like it or not. So you can use whatever style you would like to use or have. Okay, so again this one also looks good. Now moving ahead. Now we'll just talk about how you can customize your graph a bit more. Means Matplotlib even allows you to customize your graph to a very great extent, and that is what we'll be looking at is in fact. Let's say I'm generating some data, np.array, and a simple square of them. So this is my A, this is my B. And when I say simply say plt.plot AB, so you can see this is how my graph comes up. Okay, this is how my graph comes up. Now what if I want to control multiple things? For example, I'm saying you can of course control all these things are aware. But let's say you want to control even the x-text, how they want to look, whether they should be rotated or not. So all those things can be done. So you're saying plt.xtext. We have already seen this. Rotation 45, color green, size 10, alpha. So you can specify these things as well. And same goes for rotation on y-axis also. When I say plt.ytext, rotation 90. Now you can see initially they were horizontal. Now they are in a vertical format. Color black, size 10. Y limit, you can even specify a limit. Like I want all the text to be present between 3 to 15 only, and I do not want to have any other data, so you can do that as well. You can specify grid and all those things are possible. So once you run this, so this is see how your graph comes up in fact. Okay, and it's very similar to the, and it's totally on the style that we are using currently, the Seaborn V8 text basically. Okay, so this is how your graph comes up. Starts to, it is looking a bit good as well in fact, but yes. So, and again, in case if you want to know more about the flexibility and customization that Matplotlib offers, of course, you can go through the whole Matplotlib documentation as well. But again, that's not recommended from my end. Pandas and Python documentation is what I've recommended so far, and I hope that all of you have for sure gone through both the documentations by now. Okay, because those are kind of very important as well. Okay, now moving ahead. Now, it could be that you would want to have multiple plots in a same graph, correct? And this is a very common requirement, in fact. So, how to solve this? You can solve this by simply using subplots. Subplots, so having multiple graphs in a same big graph is known as subplotting. You are having multiple plots, subplots, in fact. There are multiple ways of making subplots in Matplotlib, but we'll be talking about the most easiest one, in fact, and see how we can use it for making the subplots. So I'm simply doing an aggregation at a day level for the tip and sum, total bill and tip column, and doing a sum aggregation. So you can see that this is how the sum aggregation looks. Now, first of all, I have a look at it, please, carefully. So what is happening is I'm saying two rows. Now see, first of all, to make all these subplots, we'll have to specify this particular line, like plt.subplot. So this is a function used for making the subplot. Now all these variables inside it are customizable as per your request. Now what you are saying over here is that plt.subplot, and first number refers to number of rows see over here, second number of columns, and third the plot number. So you are saying two rows and two columns. So how many intersections? So essentially you're saying that I want to make four graphs. Okay, I want to make four graphs. So two rows, two columns means four graphs. Three rows, three columns, nine graphs. Two rows, three columns, simply multiply them. Two into three, six graphs. Okay. And like if I simply make one more column, so it's essentially six graphs. So that is how this logic is. And how the graphs move. So this is the number one graph, second graph, third graph, fourth, fifth, sixth. Like it is sequential like this. That is how the numbering goes on. So I'm saying two rows, two columns. So essentially four. And in the first graph do what? Simply do a plt.scatter of tip and total bill. Marker is this. In plt.subplot, two rows, two columns, and the second graph. Day column, total bill column. Same way plt.subplot, two rows, two columns, third graph. Same way, two rows, two columns, fourth graph. Okay, so this is, and again, and this you can have totally different plots. A box plot in this, line plot in this, bar chart in this, scatter in this. So every plot can have different graphs. Okay, so now if you see, this is how it looks. In fact, this is how it looks. The fourth one is very small. So if I say tip, or what we can do is we can say word is equal to false. Okay, it's only showing the medium. So let's change the style. It's due to the style in fact. Okay, so if I say, let's say 538 and use this style, so I think the issue will be solved. So it's basically based on the style that it is not able to show the color that it is using. That is the issue. Now if you look, see it is showing this line, so it was not visible. That was the issue that we were facing. But let me use some other style. Let's see if some other style supports what we are trying to do. Let's say ggplot. Just now, as you can see, this is how the color looks now. And also just give me a second, please. Okay, so this is how our plots look like. Same way, you can have these multiple plots. And what you can do is I can even restart the kernel also and will start working fine. Just to, like if you ever face this kind of issue, you can simply restart the kernel and run all the cells again. And you have to selected cell, let's see. So we are using ggplot. Let's see now. So now we are having the color changed back to the normal part. So this is how the box plot looks like now for the tip column. Same way, in case if you want to make 9 graphs, now your question would be, what if I do not want to draw any particular graph? Is it allowed? The answer is yes. For example, if I say I want to make 9 graphs, 3 cross 3 of course indicates 9, but you are only plotting the graph in first, third, seventh, and ninth graph. So this is how they will look in fact. Okay, this is how they look. It's the rest parts will be simply blank. Only where you are plotting, those parts are visible. Rest other things will not be visible in fact. Okay, so this is how you can make multiple subplots in a single graph. Now coming to 3D graphs. Now even Matplotlib allows you to make 3D graphs. So for example, how to make a 3D graph? You have to specify this into a variable. So I'm saying plt.axis projection is equal to 3D. This way you're telling that you want to make 3D graphs. Okay, and then you simply say ax.scatter and pass in all the three variables that you would want to use to plot the scatter plot. Followed by, in this we have to use set underscore x label, set underscore y label, set underscore z label. So you'll have to follow like simply those things are same. Simply you'll have to use set underscore in front of the labels and all the titles and those things. But once you run this, now you can see that you have a 3D plot as well. Okay, so it supports tip on this axis, bill on this, and size on this axis. So it supports those things. Now the question would come, what if I want to increase the time, like the quality of the graph? When I say quality of graph, like it should be a high resolution graph. Can I do that? For example, it could be that you would want to print a graph on a page or a big page, correct? So can I change the figure size? Like I want it to be longer in length or longer in height. Can I do that? Can I increase the resolution of the graph as well? The answer is yes. How? You simply need to say fig is equal to plt.figure and fig size. So you're saying that 15 cross 5, first stands for width, second stands for height. So you're specifying 15 cross 5. Like this way you're saying that I want a longer graph and a height of 5. You can also change this like 5 cross 15. So what will happen? Shorter, but it will be very long graph as you can see. Okay. So this is what it corresponds to. And what does this 200 correspond to? This 200 corresponds to dots per inch or pixel per inch. So number of pixels increase, so does the resolution of your graph, and so does your print quality on top of images, because then you're having a lot of pixels in a single inch. That is what this says. So you can do that as well in fact. So this allows you to do that, and higher the DPI, higher will be the graph size, more time will it take to make the graph and populate it over here, because it becomes a very HD graph. Okay, now can you save the graphs? The answer is yes, you can save the graphs in PNG files or PDF files. The only thing you need to keep in mind is putting in the extension .pg .pdpng.pdf. This is how you can simply specify the extension and your graph will be saved in that format. And you can also provide in the uh, DPI feature as well, density per inch, how many, what should be the resolution of your graph. You can provide in those things as well. And how to save the graph? By simply using this fig.savefig function to save your graphs to the system, which you can share, of course, with anyone. Okay, clear everyone so far? Any questions? So this marks the end of Matplotlib for us. So we looked into multiple things just to give you a revision. So we covered a lot of types of graphs. In fact, we started with the line chart and how to make multiple lines, how to make a customized chart, then followed by scatter plot, followed by bubble plot, and then followed by pie chart. What does it indicate? Then bar charts. What do they indicate? Stacked bar charts. followed by histograms, followed by box plots along with grid and violin plots, changing the styles, customizing the graph, making subplots, moving into 3D plots, and then how finally changing the fixed size as well as saving a graph into your system. So we looked at a couple of things, in fact, with respect to Matplotlib. So now let me share this code with all of you. Please try to use your own data, your own uh, data sets along with your own types of graph that you would want to make. That for this I want to make this for this I want to make this, and try to see if you are comfortable with writing Matplotlib code. You are able to understand how to use it. You are able to go into the documentation and add multiple parameters, and you're able to make 3D plots, save them, zoom in them, try to see the quality. So let me share this code with all of you, and of course I'll be uploading it to the LMS portal as well, so don't worry on that part. So let me share this code, and please go through this. Once you're done through this, then we'll move ahead and talk about other libraries. But yes, for Matplotlib, we have completed the Matplotlib library. Go through. So I've shared the code as well as the data that I've been using. Please give a thumbs up to the file if you're able to download. And please try to play around with the graphs, change the data, make yourself familiar, make yourself confident on using Matplotlib. And once you're done with it, please write done in the chat so that we can move ahead and talk about the other library. Okay. Any questions, anyone? Please put in the chat. Ankit, we tend to use Matplotlib for making graphs, mostly for our own use case or internal use cases. But for client, if the client is a well-paying client, so we tend to use high-end tools of W, Power BI, or some other tools that make good graphs, or some advanced libraries that I'll be walking you through, like Bouquet, Plotly. You might use those as well for making the graphs. But Matplotlib is mostly used for making quick graphs, internal graphs, for you to understand how the data is. Okay. Sure. Sayyid, you need to import the matplotlib.pyplot library, then only it will be able to work. It's a very common error. The name is not defined, simply states that you have not imported the PLT part. So please import it. Then it will not give you error. Sayyid, the error states that you have not imported the matplotlib library. So you need to first of all run the cell in which we are importing the matplotlib library, and then you will not get this error. The error simply states that Python does not know what PLT is currently. How will Python know? Once you run the cell, Python will remember that okay, PLT is a matplotlib library. Very common error from the Python. Like this is the first error. If you remember, we looked into the Python programming refresher. I would recommend you to please go through those recordings as well during the week now. That is for installing matplotlib, Sundar. But the question was importing, say I did not run the cell in which you are importing the matplotlib, hence the error. Yes, Sundar, correct. Sayed, I am not able to see. What did you try? Can you share the code or snapshot? You will share the code, but yes, it will run. Like the code which Sundar has
provided in the chat, like import matplotlib.pyplot.splt, copy paste this. However, it's already present in the code and simply execute it. And in that case, it will not get the error. Ankit, I shared the matplotlib code. Everyone is currently reviewing it, and that is what is happening because we have done the matplotlib library completely. No, Lakshmi. I've shared the matplotlib code because we have done the matplotlib library completely, and the whole class is currently reviewing that and trying to use it with their own data sets, trying to plot the graphs. And if they're facing any errors, they're asking me the question. I stated that explicitly, and even the code is also present in the chat. So has everyone gone through the code? Anyone still reviewing it? Please let me know.
Okay, so let's move ahead then. I hope everyone has also gone through the code and there are no issues and everyone has understood all the components of the code and the graphs. Correct? Okay, so now let's go through another library. And first of all, I'll introduce you to that library. Do let me know once my screen comes up. Is my screen visible? Okay, so the next library that we'll be talking about is Seaborn library. Okay, so as soon as you simply Google Seaborn, you will get this first page. Seaborn statistical data visualization. Okay, and simply if you go through the initial two lines, you'll get the whole thing about what this library is. So Seaborn is a Python data visualization library. So it's a Python data visualization library based on Matplotlib. Means it completely uses Matplotlib at the backend. Okay, it provides a high-level interface for drawing attractive and informative statistical graphics. Means it's a Python library for making graphs, completely uses Matplotlib at the backend, and it gives you good interface for drawing attractive graphs. First of all, that is what this library is. And in fact, that is essentially what this library is also. Okay, so it uses Matplotlib completely, gives you very, very good graphs with less amount of lines of codes. So just to show you, for example, if I go to gallery, so first thing that this graph, this library completely uses Matplotlib. Means it's simply a wrapper around Matplotlib, and that is what they have also told. Second, then you might ask them what is the difference between Matplotlib and this library. The difference is that let's say if you want to make a graph, a good beautiful graph. With Seaborn, you'll only have to write 3 to 4 lines max, whereas with Matplotlib, you might have to write much more lines than that, double the lines in fact. Just to show, so see this is a violin plot in Seaborn library. You see, are they far good looking than Matplotlib? What do you think? Correct? What is the code for them? Like till here they're importing the data and that's it. Okay, but just this is the code for making the violin plot. You see, this is only the code for making the violin plot, sns.violin plot. And with this plot, they're able to choose good colors, able to make good graphs. So this library at the backend is completely focused on making good graphs with using Matplotlib, but with less lines of code. Same way, if I show you, for example, for histograms and other pieces, just to show you, let's say this is a line plot. See how you are able to make this time series plot with error bands. The code for it, that's it. Do you see? Just a single line code and you get these kind of graphs, which are far more good looking just with a single line compared to Matplotlib, where you have to specify X label, Y label, title, and X, Y, many more things. Okay. Same way, if you go to histograms, see, have a look at histograms. Okay. Code used this much. So what I'm trying to say is that by default, SNS library, Seaborn library will give you far more good looking graphs compared to Matplotlib with the same or less amount of code. For example, this is the box plot they are giving you. Far more good looking, correct, compared to the box plot that we looked into Matplotlib. How much is the code? That's it. SNS.boxplot. So this is really a good library. And now your question might come, then why did we go through Matplotlib? Because if you go to the homepage of this library, they itself say that it's completely based on Matplotlib. So you should be aware about Matplotlib, and Matplotlib is the most introductory library that anyone would go through when they start with the data science. Okay, so when you use Seaborn, it is using Matplotlib, but in plain sense, mostly you will be using Seaborn library only. Why? Because the graphs that it produces are far, far better looking, good looking, even for internal use and external use as well. So you can use this library a lot. And also, like for example, this is a scatter plot, okay, a continuous scatter plot, and see how good it looks, first of all, by default with default parameters. And how do we make a scatter plot? Like this, or it's a rel plot, basically relative plot, but still you're having scatters. And again, these are simply x-axis, y-axis, you're setting those things over here. So it's also highly customizable, far better graphs with less lines of code. That's it. So that is what this library is. Okay. And also to talk about one more graph which we'll be going through as well is the heat map. Okay, you pass any numerical data to it and it makes a good heat map. Code for it, a simple this code, sns.heatmap. That's it. This is the code. Okay, so quite a good library, and this is what we'll be covering in detail now. So let me open up the code and talk about this library. And first of all, let me share the link of this library to everyone so that all of you can also explore this. When is Matplotlib preferred over Seaborn? Usually, in case if you want very, very high flexibility. If I try to put it simply, can Matplotlib do all the things that Seaborn does? The answer is yes. Can Seaborn do all the things that Matplotlib does with itself, like we're using only the Seaborn library? The answer is no. Now the question comes, second part comes to it. Matplotlib can do all the things that Seaborn does, but with more lines of code, whereas Seaborn does it with less lines of code. You will use Matplotlib if your use case is very, very custom. You're looking for very specific types of graphs, and you want to have your very, very flexible or highly customizable graphs. For example, if I go to Matplotlib just to show you, just give me a second. See, if you start looking at Matplotlib examples, I think my screen is visible to everyone. If you start looking at Matplotlib examples, do you see how much customization they allow you to make multiple kind of graphs? You want to use smileys, you want to use this, that. Okay, so with different colors, means it gives you complete control. Seaborn is a subset, you can say, of Matplotlib. Okay, but the customizations that you would want to have in a graph, you can do that with Matplotlib mainly, not completely with Seaborn. Okay, in case if you want to use, for example, even if I try to show you one of the graph that was present over here, and let me take you to that, I think where it was. I think it was this. Do you see here we are setting a major formatter, correct? And what we are using? We are using Matplotlib library mpl.ticker this. Do you see? To even do customizations in Seaborn, we tend to use Matplotlib. So does it make sense what I'm trying to say? So what I'm trying to say is that Matplotlib allows you to customize to a very, very great level. Seaborn is good with making graphs. You can do the customizations, but with help of Matplotlib. But less lines of codes, similar graphs, you go with Seaborn, and beautiful graphs, in fact. Yes, correct, Prakash. The default graphs for Seaborn are very, very good. Like this is the default scatter plot now. I can call this scatter plot. Okay. Again, it simply is having different bubbles also. We'll look into that, but they use it like RL plot basically. But yes. So quite a good library. And again, just to talk about Matplotlib as well, just see how much customization it allows you. You can even have a histogram with respect to a pie. Okay, directly there is no graph in Seaborn that allows you to do this. And directly there is no graph in Matplotlib also that allows you to do this. What you are doing is you're customizing this in such a way that you can make this kind of graph. Okay, so that is where Matplotlib allows you this functionality or flexibility. Now the question comes, can I do this customization in Seaborn graphs? The answer is yes, but only with the help of Matplotlib library. Okay. So any questions, anyone? Any doubts? Yes, Toby, because Seaborn at the back end uses Matplotlib only completely. So that is what I was showing in one of the graph. If I recall which graph was that again, just give me a second. I think it was histograms only. See, I'm using MPL tickers. And what is MPL? Matplotlib. I'm importing Matplotlib as MPL. And inside this axis part, see, first of all, I'm using the subplots. And inside the subplots, I'm plotting the histograms. Do you see? So what we are saying? We are making a subplot, plt.subplots. And then I'm using Seaborn to make the graph. And then I'm again using Matplotlib tickers and formatter over here. So both can be used together, in fact, and very easily. Because as I mentioned, Matplotlib is simply the backend of C1. Yes, Ankit. Does it make sense to be Ankit? Okay, perfect. So, and again, just to mention, this is also a completely open source library, means they do not charge you any money for using it, but there are various visualization libraries that tend to charge money. Okay, but yes, this is completely free library, and the whole source code is present on GitHub, and the language that is used completely is Python, as you can see over here. And there are 203 contributors to this library and used by approximately 600 key people. And the latest version that was released is in January. So again, the whole source code is present over here that you can have a look at, and how it was developed and all those things, in case if you're aware about Git part. But yes, so quite a good library and open source, free to use. So let's do one thing. We'll start with the Seaborn code in the next class itself. So in next class, we'll complete the Seaborn as well as the other libraries that I'll give you an intro to. And then we'll start moving into the statistical and the probability distributions and those concepts, in fact. So stopping the share. Now, if you have any questions, please put in your questions. And in case if you don't have any questions, Shri Krishna has already shared the feedback link. Let me reshare it. So I've shared the feedback link. Request you to please provide your feedback, and then you can drop. And in case if you have any questions, please put in your questions. Then I'll answer. You can provide the feedback and then drop. Thank you, everyone. Those who are leaving. Yes, Prajita, you can see that. Thank you, Sundar. So, any questions, anyone? Please put in. Thank you, Toby. Thank you, Ginder. Thank you, Abhishek. Okay, so I do not see any questions coming up. So thank you, everyone. I'm also leaving the session. See you next week. Thank you, everyone. Bye. Thank you, Sayed.